All right, this is chapter 11 off of the semester test review. 11A is find the area of triangle ABC. So triangle ABC is not a right triangle, but we do know that the area formula of a triangle is equal to 1/2 base times height. Do we know the base and do we know the height? There's our height h. There's our base of 4.3. Multiply that out, and if you guys will assist me with the calculator work, 1/2 4.3 times 9.4, somewhere in the neighborhood of 17, I think. 20.2, man, I was way off. Is that approximately, or is that it's actual equal?
No.
20.21 centimeters squared. 20.21 centimeters squared. Okay. Well, look back at our units and we can see by unit analysis that we have centimeters times centimeters, so that would be centimeters to the second power. Volume is generally going to be cubed. Find the area of the square with diagonals of 15 square roots of 2. So I'm going to draw myself a square, and the diagonal is 15 root 2. Things we know about a square: right angles for corners. That means that's a right triangle. We also know that all four sides are the same, making this two isosceles triangles. If this is an isosceles triangle, then those two angles have to be the same, and the only measurement that they could be is 45 degrees. Not that it matters, but this is a 45, 45, 90 triangle, and if you know 45, 45, 90 triangle properties, then you already know how long the side is. Okay, because 45, 45, 90 is going to be A, and A root 2. So how much is A? A is 15. Good. All right. The other way we could have worked this is just good old-fashioned Pythagoras Theorem. Since this is a 45, 45, 90, since it's isosceles, then what I really have is this. And I can just say x squared plus x squared equals 15 root 2 squared. X squared plus x squared is going to be 2x squared. When I do this, I'm going to have to do 15 times 15 and square root of 2 times square root of 2. So 15 times 15 is going to be 225, or 15 squared. Root 2 times root 2 is going to be root 4. Okay. Well, root 4 we know is just going to be 2. And when I divide both sides by 2, those both go away, and I get x squared equals 225. But you know what? I just found 225 by squaring 15, so square root of 225 must be 15. However, even though it's supposed to be positive or negative, in geometry we don't have to worry about the negative version because this is a length, and lengths will not be negative, so it's just going to be x equals 15. Thank you, 15 centimeters. Don't forget your units. Thank you. We have just found x. X is a length, so it's not the area. It would not be squared. But we are going to need to use that to find the area. So if we're doing a triangle, we got base and height. Let's use a different color here. Doesn't really matter which one we call base and which one we call height, but it's basically going to be 15 times 15. So the area of the triangle equals 1/2 of 15 centimeters times 15 centimeters. So the triangle is going to be equal to 225 over 2 centimeters squared. So is that 112.5? What is it? 112.5? All right. That is the area of one triangle. The area of the square is going to be 15 times 15. Say again. This was the area of the triangle. This is the area of the square. Okay, I'm going to clear the screen. If I can figure out. Oh, that's not. Yeah, if I knew how to do that, that'd be great. I know there is a clear ink. Okay, probability. Find the probability of hitting the shaded region. So, with probability, we are looking at what is the area of the region we want and what is the area of all the possible region. Okay, so probability is equal to the part that we want over the whole or total area. Okay, the part that we want over the whole or total area. So the first question is, how do we find the area of the part that we want? The part we want is this donut. And we've talked about how to find the area of a donut back whenever we talked about areas. What do we do to find the area of a donut? Subtract the ends. It's like punching out a ring, right? We punch out the middle, so we're going to take it away. We're going to subtract the area of the large circle minus the area of the small circle should equal the area of the donut. All right, so the large circle is going to be pi times 7, and they didn't give us any units here, pi times 7 squared, minus the area of the small circle, which is pi times 3 squared, and that's going to be 49 pi minus 9 pi, which equals 40 pi. Now, I'm not a big fan of this, but the EOC does use pi in terms of 3.14. So if it asks you to use 3.14, then follow those directions. If it does not say whether to use 3.14 or not, then go with whatever you feel, and you should not be too far off. We should not put two answers that are that close that 3.14 versus 3.14159, the calculator's version, should make a difference. So 40 pi, and then we need to plug in pi of 3.14. So the area of the donut is equal to 40 times 3.14. That's going to be 120.56. 125.6. 125.6, and there's no units, but we can just say units squared. Okay. Let's clear this and move on to the next one. So how are we going to find, I'm sorry, my bad. That was, we didn't actually finish that. That was the area of the donut is equal to 40 pi. The area of the total is equal to 49 pi. So the probability of this, the probability is equal to 40 pi divided by 49 pi. The likeliness that we're going to hit it is the area of the part we want to hit over the area of the total thing. And now the pi's are going to cancel out, not even factoring in, so we don't have to deal with 3.14. And 40 divided by 49 will be somewhere around 81%-ish. Put that in. .816, so 81.6%. Okay, which is also we need to be able to convert back and forth between percent and decimal. Okay, so number 11D. 11D. Oh, edit. Here we've got the area of this leftover, the area of this cutout is going to be the area of a square minus the area of a circle is equal to the area that we want. I just don't have a real good name for that. So the area of the square, what do we know about the square? 15 foot on a side. So it's going to be 15 feet times 15 feet, since these are the 15 feet as well, minus the area of the circle. What do we know about the area of the circle? Pi r squared. What is r in this case? Good. So it's pi times 7.5 feet squared. All right. So the area we want is equal to 225 feet squared, and 7.5 is going to be what? 20 squared. 220, 112, no, what is that? 56.625? I don't know. 56.25? Yeah, 56.25. So minus 56.25 feet. Sorry, what? Yeah, thank you. The 56.25 feet, pi feet squared. Okay, now guys, you could go ahead and find the decimal right now, and that probably wouldn't make a difference. So let's go ahead. If we were to do any more calculations, I would rather you not put in the pi until the very end. Okay, but at this point, just because I know what's going to happen, it's not going to hurt to find the decimal. So when we go for probability, probability is going to be the area we want over the area total. Well, the area we want is 225 feet squared minus 56.25 pi feet squared divided by the total area. What's the total area? Yeah, it's going to be the area of the square again. So it's going to be 225 feet squared. So plug that into your calculator just like it is. 225 minus 56.25 pi over 225. And I won't get trying to guesstimate here. I'm going to figure it's somewhere in the neighborhood of, I don't know, 30 to 40%, something like that. But what are you guys getting? .75. 48.775. Let's do this. What's 225 minus 56.25 pi? What's that going to be? And go ahead and plug in 3.14 because they told us to. Instead of using your calculator's version of pi, plug in 3.14. Should be somewhere in the neighborhood of 70, 60 something, 70 something, maybe 50 something. 225 minus 56 times 3.14. 56.25 times 3.14. Okay, so 48 is the answer to this part. 48 point, what did you say it was? 375 feet squared. Now that's just this part. Next, divide that by 225 feet squared. So 21%. So 0.215, which is 21.5%. I was way high. 30. I said 30 or 40. That's way high. I was a bit off. All right. And guys, remember, all this is going to be on the internet, on YouTube, so you can always come back and review what we're doing here. It's important that you guys don't just think this is done because you've went through it with me once. You've got to go back and cover these problems up and try them again. That's the whole point of the review. Otherwise, you're just undermining yourself. I'm undermining you because I'm giving you guys the answers and I'm not giving you a chance to work them on your own. Okay, two regular hexagons have sides that are 4 inches and 7 inches long respectively. Find the following. The ratio of their sides. They did not tell us which way to go with the ratio of their sides. Okay, they did not say the ratio from the larger to the smaller. Okay, so in the absence of directions, I would always just start with the first one, go to the second one. Be the easiest. Okay, so 11E, the ratio of their sides. Well, the side of the first one over the side of the second is going to be equal to 4 inches over 7 inches, and inches over inches reduces, which we now correctly have a ratio because ratios don't have units. Rates have units, ratios don't. Okay. How about the ratio of their areas? The ratio of their areas. Now, we could go through very tediously finding the area of the first divided by the area of the second. Now, we know that the area of a hexagon is going to be 1/2 perimeter times apothem. And so this is the perimeter of the first times the apothem of the first, perimeter of the second times the apothem of the second. And we could go through and we could even see that, look, the 1/2s are going to go away. So now we'd have to see that the perimeters are going to be different. The perimeter of the first one's going to have 4 inches on each side, and the second one's going to have 7 inches on each side. But how many sides do they have? Well, perimeter is equal to, let's see, 6 sides times 4 inches times the apothem of the first. And then the perimeter of this one's going to be 6 times 7 inches and the apothem of the second. Well, the 6's are going to go away. Now, the apothem of the first and the apothem of the second is going to be based off of how long the sides are, and we can find that using a 30, 60, 90 triangle. Remember, we went through and we did trig. You guys had a, pardon my horrible drawing here, you guys had a hexagon And you found out that if you were going to divide it up into triangles, each of these triangles' angles was going to be 1/6 of 360, which is how much? What's 1/6 of 360? It's 60 degrees. Yeah, 60 degrees. That means that if I cut it in half and pull this triangle out, then I have a 30, 60, 90 right triangle. And the only thing I know about these triangles is they've got some side length. In one case, it's 4. In the other case, it's 7. So this is going to be half of whatever that side length is. Okay. And then what can I use here? Well, if I knew one of these other sides, I could use a squared plus b squared equals c squared. But I don't know one of those other sides. I'm going to have to go with something that uses angles and sides. What is that thing that uses angles and sides? What allows us to convert back and forth between angles and sides? Something new we learned this year. Say again? Trig Sohcahtoa, right? If we have an angle and we want to find a side, or if we have a side and we want to find an angle, that's where we go with Trig Sohcahtoa. Now, you could memorize your 30, 60, 90 triangles, which 30, 60, 90 said that this hypotenuse will always be twice whatever the small angle, the small side is. That doesn't really help us in this case, but this one right here is going to be square root of 3 times this small angle. Now, guys, I am going the long way about to show you something here. Okay? I'm going the way that you would have to do if you were going to work these out. If you were going to find the area of these and try to figure out what the ratio of the areas are, you'd have to find the area of one with a 4-inch side and the area of one with a 7-inch side. But here's what I want to show you. Let's do this thing here. This is the apothem, 1/2 a times the square root of 3. Or you could just say that's, we'll leave it like that. So if I put that in here for the first and put it in here for the second, here's what I'm going to get. 4 inches times 1/2 of 4 inches, because A was the length of this side here, and it was 4 inches in the first one, square root of 3. What do you guys notice? Is there anything similar in the top and the bottom? What's going to happen with 1/2 over 1/2? It's going to have a square root of 3 over square root of 3. It doesn't matter what the formula is, guys. It doesn't matter that this formula is 1/2 apothem times perimeter. It doesn't matter if it was 1/2 of a, length times width, okay, for triangles. Doesn't matter if it was length times width. What you're going to find out is all of the formula, like this first 1/2 here, and this 6, and this 1/2, and that square root of 3, all of the parts of the formula are going to cancel out, and the only thing that is left is the sides that were used in the formula. And because it's area, how many times did we use those sides? Twice. We will always use those sides twice, which makes it squared. So, forget all the stuff we did here to find the formula. And just go back to this idea that if I have area of the first over area of the second, it's going to be that thing squared. Now, we talked about this whenever we talked about digging the hole, and we said that, hey, if you dig a hole twice as deep, twice as wide, and twice as long, then your volume's actually going to be times 8. Okay? It's not just times 2, it's times 8. Well, the same thing with area. We said if we just made a pizza, what's the difference between a 6-inch and a 12-inch pizza? How many 6-inch pizzas does it take to make a 12-inch pizza? How many 6-inch pizzas would you buy to replace one 12-inch pizza? 4 6-inch pizzas. We had a whole day of talking about this, guys. Okay, so I'm not going to go back into it, but you just need to know that it's always going to be the ratio squared. Since the 12 inches double, you're going to square that to get 4 pizzas. And finally, the ratio of their perimeters. If the ratio of their sides is 4 to 7, you would say 4 over 7. Well, that'd be 4 times 6 over 7 times 6. What's going to happen? The 6's are going to cancel, and what's your ratio? So the ratio of the perimeter is the same as the ratio of the sides, because the perimeter is just a sum of sides. This is back when we talked about one-dimensional, two-dimensional, and three-dimensional, right? We said this is a one-dimensional rate. Squared is a two-dimensional rate, and if we go up to volume or weight, that's going to be a three-dimensional weight, and it would have been the cubed. Okay. Find the area of each shape below, guys. This is just using our trig. We're going to need a little trig here, and we're going to need our area formulas. What's our area formula for a trapezoid? It's going to be on the test. You're going to have a sheet there that you can look it up, but does anybody remember the area formula for a trapezoid? Who's got a book in front of them? Nobody? Eddie, you got a book back there. What is it? What do you got? Okay, 1/2 of height times. Yeah, that's the way it's got it in the book. Now, I prefer to put the divide by 2 over here instead of in front. What is base 1 plus base 2 divided by 2? Take two numbers, add them together, and divide them by 2. What are you doing? Average. So we're taking the average of the long one and the short one. What's the average of 12 and 8? What's halfway between them? Yeah, it's 10, okay? And that makes sense because, look, if we turn this one down, it fits right there. If we turn this one down, it fits right there. So really, this is just a rectangle with a top and a bottom of 10. So we need now to find the height because we don't know the height, and this is the height right here. But I can use Sohcahtoa. I can use trig. If this is 54, that makes this opposite, and that makes this hypotenuse. What uses opposite and hypotenuse? Right. So uses opposite and hypotenuse. So I'm going to say, look, the sine of 54 degrees is equal to the opposite, which we don't know, over the hypotenuse, which is 7 inches. So now I could call the opposite h if you guys want me to. There you go. Make it a letter instead of a name. To get rid of 7 inches off the bottom, what do? If I want to get h by itself, I got to get rid of 7 inches off the bottom. What do? Divide by 7? Multiply by 7 inches. Good. Whoa, man, what happened there? There we go. There we go. Okay. Those 7 inches will reduce to be 1. And so h is going to be approximately 7 sine 54. What's that going to be after it's going to, what'd you say it was? 5.66 inches. Okay, that sounds about right. Now I'm going to plug that in and use that for the area of the trapezoid. So the area of the trapezoid formula that we got up there Base 1, which is 12, plus base 2, which is 8, divided by 2, times 7 sine of 54 degrees. Remember, don't ever do any more calculations with something that's already been rounded. Don't plug in 5.66. Put this into your calculator. So 12 plus 8 over 2 is actually going to just be 10 times 7 sine 54, which is going to just be 70 sine 54 degrees. So is that going to be 56.6? Put in your calculator. 70 sine 54. See if that's 56.6. Anybody going to corroborate my story? Is it 56.6? Yay? Okay. So, by the way, this was inches plus inches, and this was inches. So when I got done, this was 10 inches times 7 sine 54 inches, and that's how I got inches squared, because inches times inches is inches squared. So the approximate area is 56.6 inches squared. Wow. Somehow I just cleared the page. Let's see. I don't want to clear the page. I want to clear the ink from page. Okay, so yeah, Mr. Conaway obviously doesn't know what he's doing. So let's see. That'll work. I'll just have to do it this way. Okay, back up front, guys. Shh. So once again, we are now we're looking at a parallelogram, and we're going to have to find the height. And once again, we're going to need to use trig. So trig up here to find h, we're going to use sine. So sine of 33 degrees is equal to opposite, which is h. I'm sorry, we're not going to use sine. This is adjacent. So we're going to use tangent. So tangent of 33 degrees is going to be equal to h over 2 feet. All right. Multiply both sides by 2 feet. And you're going to get h equals 2 tan 33 degrees feet. But that's only the height. Now, what is the area of a parallelogram formula? It's base times height, which the height has to be perpendicular to the base, right? That's kind of the definition of an altitude, is it's perpendicular to the base. So yes, base times height. The base, we already know, is 15 feet. And the height is going to be 2 tan 33 degrees feet. Plug those into your calculator and give me an approximation of it, please. So 30 tan 33 feet squared. What is it? 19. And if I get these wrong, I don't got a calculator up here. So does everybody agree? 19.5 is right? Okay. Let's try this again, see if this will work. Clear ink. All right, it worked that time. And let's, whoa, whatever. Seriously. You don't have to be so angry. Okay, 1/2 perimeter times apothem. We just did that a while ago. We're going to have to do it again. So we need to find the apothem, the perimeter of the area of a pentagon is equal to 1/2 perimeter times apothem. Well, the perimeter on this thing's pretty easy. The perimeter is going to be 5 sides times 12 meters on a side. The question is, what is going to be the apothem? What's going to be the apothem? So to find that out, the apothem is like the radius. It's the shortest distance from the center to one side. The shortest distance from the center to one side. What can I use here to find that? Yeah, a squared plus b squared equals c squared. By the way, I don't believe this is an actual pentagon that it can exist in reality, because I don't think you can have 10 and 6 with a 72-degree angle here. I might be wrong, but I don't believe you can. So 6 and 10, though, let's just use a Pythagoras Theorem, and we're going to be 6 squared plus x squared, we'll call it h. 6 squared plus h squared equals 10 squared. So h squared equals 100 minus 36. H squared equals 64. H equals 8. We don't have to do positive or negative 8 because it is the length of a side. So that means the apothem here is 8. The apothem is the shortest distance from the center to the edge of the pentagon. It'll always come at a right angle, because if I wanted you to walk to the wall, you would always walk at a perpendicular line to the wall. Okay, so now I'm going to go back up here and put this in at 8 meters. And just for giggles, just because I want to know, if this is sine of 72, somebody plug that in your calculator and tell me what that is. Sine inverse of 6 over 10. Calculator, sine inverse, second sine button. Oh, man, what am I doing? 72. 36.86. Okay. Yeah, it's supposed to be 36, which is half of 72. Yeah, so, but still 36.86. It's close, but it's off by, it's about 37 degrees. It's supposed to be 36 degrees. Okay, so that one's good. Multiply all this together, and you're going to get the area of the pentagon is equal to 30 times 8, so 240 meters squared. 240 meters squared. 36. Whatever day you take first hour test. Okay, the final one, guys, 11K. I'm going to say that on this, the only way you can solve this is if you assume that that is half of a circle. Okay, it'll tell you to assume it, or you'll just have to assume it. But that's got to be half of a circle. Half of a circle with a diameter of 8 means that I'm going to do the area of a circle plus the area of a triangle, area of a half circle, plus the area of a triangle to get the area total. So area total equals 1/2 pi r squared, and r is 4 centimeters squared. That's the area of half of a circle, plus 1/2 base times height, which is 8 centimeters times 17 centimeters. So multiplying that out, that's going to be 16. That's going to be 8 pi centimeters squared plus 4 times 17, that's 68 centimeters squared. Add those together for me, and it should be somewhere in the neighborhood of 93. Is it really 93.12? Okay. All right. Good work, guys.